Hello everyone, welcome to the third lecture of CS 527. So in my first two lecture, I have explained you the basic concept of computer system which will be required in this course. I hope you have cleared all the basic concept of linking and linking, debugging, and whatever additional task given to you. So as I promised in last class that from today onwards I'll start teaching from the content of textbook, but today I'll not start from chapter 7 because chapter 7 is for linking, and as I have mentioned in my first class that the chapter 7 will not be covered completely. I'll only cover the important concept of chapter 7, but the actual content means the initial understanding of chapter 7 is already given to you. You already know what is called linking and loading, right? So what I have decided that I'll come back to chapter 7 after a few lectures. So that's why today I'll start the next chapter, but again in next chapter also I'll not discuss the initial theoretical part. I'll today what I'll do today and maybe in this week all three lectures will be practical. I'll try to explain you some programs and all in today in these three lectures. Then after completing and all this practical part, then I'll go and quickly cover the theoretical part of the theoretical content of this chapter, that is chapter number 8. Okay, so today we'll start understanding the concept of process. So as I've said that if you want to know more theoretical things about process, then read any computer system book, because in this course I'll not explain the theoretical part more. What I will say and that the definition of process is it's a program in execution, right? And each process has its own address space. Own address space means inside this address space it will store its data, it will store its code, it will store its stack, it will store its heap and all other things. So I hope you know when we use stack and when we use heap. We use stack to store the local variable, we use heap to store all the dynamic memory locations, right? So I hope all this thing is clear. If it is not clear, please clear it by yourself. And so for today you have to understand only one thing, is that each process has its own address space, means all the variables and everything are stored in its own address space. All right, so what I'll do today at the beginning, I'll try to run a code, and from here I'll start. I hope you can understand the concept of this program. It's actually running infinitely, right? Let me compile it. Yes, it is compiled. So if I run this code here, it is running infinitely. So my intention here is to show you what is called process. So as I said, process means a program in execution. So what we have done here in the first line, we have compiled the code. And when we have compiled the code, a executable file will be created called a.out. Since we have not given any specific name, the name of the executable file will be a.out. So after this, the second line, we have written this command. So by this command, what we'll do, the loader will load this program to the computer and it will start executing. The moment this a.out start executing, it becomes a process. That's why I said a process is a program in execution. So it start executing. So the moment you write this, it is start executing. At this moment, the program is actually executing in this laptop. Okay, so now if we want to see all the processes, then you can use one command, ps minus af. If I go for this command, so see here, you can see that this is the program that a.out is currently executing. This is the process. So the process ID is written here. This is the process ID 7912. So the program that you have executing now, this is executing. So there will be a process. So you can see here the process is actually process ID 7912, and it is running in core 1. It is running in core 1. So you have to understand this PID is the process ID, and this PSR, it is saying in which core it is executing. It is executing in core 1. So always remember one thing, that whatever command, whatever cell command I am using, you should also understand what I am using. If I am not, see, I will not explicitly explain what I am doing with ps minus af, but you can also search it by yourself and try to understand what I am doing here. So actually, in short, if I say that if I go for ps minus af, then it will show you all the active process that is running now. So this process a dot out is now running, so that's why it is showing that the process ID is this. So now let me stop this. To stop this, because it's running infinitely, if I say Control C, then stop. So if I now go here again and write again, see, a dot out is not here. A dot out is not here. It was here. Previously it was here, but now you can see this is the active program list. In active program list, a dot out is not there. So now what I'll do, I'll compile it with minus o, and I'll store it in out.o, right? Now it is stored in, now let me run out.o. If I run out.o now, and then now again, if I want to check all the active process, see, you will see out.o is now running, and the process ID is 8220. This is the process ID, and the process is executing on core 1. Okay, I think this part is clear. Whatever I'm showing here is clear to you, right? So now next, what I will do, I'll try to go for a command called fork. Okay, before going to fork, let me explain you one more concept. That concept is called how to get the process ID. Okay, while that loop is actually required, I cannot ignore this loop because I want to execute the program infinitely. Okay, so boolean flag equal to false, then I'll write PID underscore T. This is for storing a process ID. Now try to understand this program. What this program is saying, initially it is going for a flag, and then just you need to concentrate on this while loop again. This while loop. So if you see, the while loop is again executing infinitely, and at line number 13 it is going for a sleep again for 2 milliseconds, and then again it will continue. We repeat the same thing. Only exception is this part, but this part will execute only once, right? Because if integer flag is 0, then only it will enter here, but whatever it will do after doing some processing, then it will change flag again back to 1. So this part will execute only once, first time when it will enter a while loop, and after this while loop will just infinitely executing. It will go for sleep, and then again it will execute, right? So again, actually this while loop, the main intention here to write infinite while loop is to show you something. I want to just keep this process executing. Otherwise, if I don't go for while loop, then this process will just start and immediately complete this program, and it will stop, it will terminate. So what my intention here is to keep this process live, so that I can explain you some other concept. That's why I'm using an infinite while loop. Okay, so what this flag, the if is doing, if is using a get PID. Get PID is the function stored in this header file, which can give you the process ID of this function, or process ID of this program. When this program will execute in computer, then the process ID will be given by this get PID. Okay, so what this if statement is doing, if statement is actually printing the process ID of of the same process, and then it is converting this flag as 1, and then it is forcing this printf statement to be printed in the output. Std out is means this terminal, this particular terminal, and then again it is just infinitely executing. So let me compile this code. Okay, if any of this program that I am writing here is not clear to you, then please try to understand by yourself, because this is very basic. But even if it is not clear, you can ask me. But these I'll share some program with you, but that these program may not be exactly same to same program. But yeah, similar program I'll share with you. Mostly those programs are written in my in last time. But since I am actually recording a video, and when I record a video, I usually type my own programs at runtime. So maybe this program will not be exactly the same. Okay, so let me just compile this code. See, this program is now compiling. So after compiling, let me run this code here, out so now the program is running. So what this program is doing, as I said, first time it will print the process ID. So it is saying the process ID is 9160, and now it is keep on executing, so now to verify you, let me use this command here, ps-af. So what this command is doing, this command will also give you the list of all the processes that are currently active. So this command should give you out.all also. See, this command is also giving you out.o. This is out.o, right? And what is the process ID? See, it is the same thing, 9160. So this, I think this function is giving correct output. So the process ID is 9160. You can also see it from here, 9160, and it is running on port 1. So I hope this part is clear, that how to get the process ID. Okay, and how to check the list of active processes in Ubuntu, that I have already explained. Now I'll go for I'll delete all this thing, and instead of all this thing, I'll write here fork, fork, and after this, I'll write a printf statement. So, what do you think? What should be the output of this program? It's a fork. What should be the output of this program? Let me compile this code first of all. Okay, it's compiled now. So, if I run this code, let me run it also. See, it is printing hello world twice. So don't just ignore this line. There was some issue with terminal because this terminal is very small here. I have compressed it. So that's why it is showing this line up. But actually, it is showing hello world twice. Actually, ignore this line. Okay, it is showing hello world twice. Okay, so why it is showing hello world twice instead of once? Because of this, the statement written in line number 4. That is called fork. This for statement creates a new process, creates a child process. Okay, it creates a child process. So the every time, the moment we execute a fork statement, after this fork statement, which is the line is 4, right? At line number 4, we are executing a fork statement. The moment you execute a fork statement, from the next line there will be two process. One is parent process, the same process, and there will be another process. It's called child process. Again, I'm explaining you from the beginning that if you write a program like this, then you have to first of all compile this code. After compiling, when you will try to execute it, then that from that moment your program is a process, because now it is executing. As I said, now any program, the program is in execution, is called a process. So but I am just explaining in terms of this program, but actually what I am saying here, it's only true when you run this program, you will execute this. At that time, when there will be a fork statement, that from after this fork statement there will be two process. One is the parent process, and another will be child process. So from the next line, this is, since after line number 4 there will be two process. So from the line number 5 will be executed in two different processes, not just one process. So this is a very important concept. So you have to understand it. That what I am saying here, up to line number 4, we have only one process, right? Only one process. But after line number 4, whenever we want to go for to execute line number 5, there are two process. I can say P2, P1. There are two process. Actually, P1 is the original, that is called parent, and P2 is the new process created, it's called child. That is two process. So the line number 5 will be executed not just by one process, it will be executed by two process, P1 and P2. So to explain you it in more detail, what I will show again, I will use a infinite. Let me use one infinite loop again, so that the process should I can keep this process alive for some time. So slave to. So now before going to executing it, try to understand the code. Line number 4 is saying there is a for statement. After this for statement, Previously, there was only a process called P1 till line number 4. The moment after the line number 4, from line number 5, there are two process, right? One is P1 and another is P2. That is a child process. Now there are two process, and these two process both will start executing from the next line of work. So the next line is line number 5, which is printf. So both P1 and P2 will print hello world, and then both process will go to while loop, and it's an infinite while loop, so the both process will infinitely execute it. So you have to only understand that after fork there are two process P1 and P2, and they are independent process, they are not related at all, so they will independently execute. So let me run this code again for you. Let me compile it. Okay, and then let us run this code. See, hello world is printing twice. First hello world is for P1, second hello world is from P2, and now they are executing infinitely. So now if I go here and try this, you'll see there are two out.o. Out.o. There are two out.o. Why there are two out.o? Because we have started with one out.o. Which out.o one we started? We started with this one. 9729. This is the initial process. Up to line number 4, this was the initial process. After line number 4, the moment we go for fork, it has created another process, and that process ID is the next one, 9730. And now the two processes are executing. Now there are two processes are executing here. You have written one program, we have loaded one program here, out.o, but this out.o is now executing two processes in your system, and the process IDs are all. And you can see here both the processes are running on core 0. How is that possible? Yes, it is possible, right? Two processes can execute in one core. That's completely fine, but they will not run in parallel. They will run in concurrent way. Concurrent way means when one process will execute, they will execute in a context switching manner, right? You know what is concept of context switching. So first one process will execute, and if whenever there will be input output or something, then that process will be suspended, and the another process will execute. So it's possible. You know the concept. It's called multi-programming. Okay, so the both process you can see are running on core number 0. But I think this concept is clear that what is the purpose of fork. So now I'll go for a more little bit complex one. A fork, a fork, a fork, a fork. Now what do you think? How many time this hello world will print? Let us just compile it and run it. Okay, okay, these things I should remove, or let me write some command line here so that I can use it as a test pad. Okay, now compiling it out.o. If I go for out.o, how many time it will print? See, it is printing for how many times? It is printing for at least 8 time, I think. It should print for 8 time. Why it is printing for so many times? Let's start from line number 4. Till line number 4 we have only one process P1, right? After line number 4 we have two process P1 P2, right? We have two process P1 and P2. After then line number 6, line number sorry at line number after line number 4 we have two process P1 and P2, so line number 5 should be executed in both P1 and P2. Okay, so let us first execute line number 5 on P1. So in P1, whenever you will execute line number 5, again it's a for statement, so again it will create two processor. So it will create P1 and maybe P11. Okay, okay. Now let us go here in P2. For this process, again run line number 5. See, line number 5 is again a processor, again a for statement, so it will again create two process. First is parent process, and from parent process it will create another one, 2 1. Okay, that's at the end of executing line number 5. Then we'll go to line number 6. When we'll go to line number 6, then again it's a for statement, but that statement has to be executed in all the four processes. So when we'll execute in P1, it will, this is the parent process, and it will create one more. Suppose this is 1 2. Okay, and when we'll go here, this is the parent process, and it will create one more, P1 1 2. Suppose when we'll go here, it will create, this is the parent process, and it will create one more. Sorry, it's supposed to 1 1. And when I'll go to this one, it will, this is the parent process, and it will create 2 1 2. Suppose, don't go for the numbering, but just try to understand it. So now how many process are here? 1 2 3 4 5, 6, 7, 8. There are 8 process. So all the 8 process will execute line number 7. So there will be 8 hello world printing here. You can see there are 8 hello world printing, and then all the processes are now executing infinitely. So if I go here and I use this command again, then you can see how many numbers out. You can see here, see out 1, 2, 3, 4, 5, 6, 7, 8. 8 out out dot o are there, and all these processes are running. These are their process IDs, and you can see they are either running on core 1 or core 0, right? So I hope this fork concept is clear. It's not just and we have just started the concept. One by one we'll build the story and we'll go in a more complex direction. But I hope this first point you have to understand that after this fork, how there are two processes, one is the parent and one is the child, and how immediately next line is started executing in both the processes, that you have to understand. Okay, so I'm deleting this code again. Always remember a few things. So just note down these header files and all, and then only you can write the proper code. But these are easy code, so I'm deleting it again. Okay, and this time I'll not go for a while loop. I'll just go for integer x equal to 12. Suppose there is a processor, and then I'll go for PID underscore t. This is actually a variable assigned in this header file, which can be used to store a process ID. Actually, it's an integer PID t. So at PID t, I'll go for suppose p is a variable or to store process. Better I write PID. So PID t underscore t is actually data type. Okay. So now here I'll write PID equal to fork. Now actually what I'm trying to say here, that in our previous code, what it was written after fork, there was a print line here, na? Printf, and that printf we are executing like it was hello world. Okay, and what we said that this hello world will be executed by both. After line number 6 there will be two lines, right? There will be two processes, and both processes will print hello world. So there will be two printing of hello world. That is fine, but uh, till now I just use fork. I have not explained you what fork is returning. It's a function, and it always returns something. What it's return? It's return a process ID, and this is the beauty of a fork function. It is called from the parent function. Sorry, it's called from the parent process, but it return in both parent as well as in child. Please understand the point that I'm saying. The fork is a function which is called from parent process, right? Because we're calling from parent process to create a child, but the function, the value of this function will return in both parent and child. So what it will return, but the values will be different. So after this for statement, there are two processes, right? Child and parent. So in child, the value of PID it will return as 0 always, and in parent it will return the PID of the child. So let me show you. If PID equal to 0, you have to understand that this is child. Else, this part is parent. So if I write here printf, this is child process. Okay, and if I write here this is parent process, if I write this code, then let me run this code here, and then you'll understand the difference. See, it is printing this is parent process, this is child process. These two lines are printing only once. Even if you go up, no need to go up. See, these two lines, this is child, this is parent, these are printing only once, but the hello world is printing by both child and parent. So let us again check this code and try to understand. These small things are very important. If you are familiar with all these things, then it's very nice. If you are not familiar with this, try to understand this point again. What I'm trying to say here, fork is a function which will return a PID, and that PID will be returned in both child as well as in parent. And as you know that the concept of fork is the line, suppose line number 6 is for fork, so from line number 7 both the process will start executing. You have to understand this, right? From line number 7 both processes are executing. So how you will differentiate that, okay, this is child, this is parent, that you have to find out from PID, right? As I said, after fork, the function fork will return 0 to child, and it will return the process ID of its child to the parent. So since after this for statement line number 7 will start executing in both the process, then at line number 7 only I'll check that if the PID is 0 or not. If the PID is 0, then I'll understand that, okay, this process is child process, so here I'll execute only this part. So child process will never enter here because there is the if part. Okay, and for a parent process will never execute 8, but actually both will start executing from 7. Both child and parent will start executing from 7, but there is a if condition, and if condition is saying parent, you directly go to line number 10, and if it is child, you go to line number 8 and then directly go to 12, right? That's why what it is happening after line number 6, child will get PID as 0. So if PID is 0, child is only printing line number 8, and it is jumping to line number 12 and it is printing hello world, right? And what parent is doing after 6, it will also start from executing line number 7, but at line number 7 it is checking PID will not be 0. PID will be a positive number. It's the ID of parent, sorry, ID of children. So it will go here at line number, it will print line number 10, and again it will jump to line number 12. So both are printing hello world. So I hope the concept is clear. To make it more clear, let me again use here a infinite loop. An infinite loop is, okay, this is an infinite loop. So now what I'll do, uh, let me print the value here, PID. What I am doing, I'm trying to print the PID at parent. No need to print it child, because in line at line number 8, I know the value is 0. That's why it is entering in at line number 8, right? But at line number 10, it's the non-zero value. We don't know what is the value. So let us print it. Okay. And again, if you understand line number 13 here, then I think you are understanding that both process after printing hello world, they are constantly, both the process will constantly executing that I want. So let me compile this code again and run it. See, it is printing as expected, and now it is continuously running. But only change it, that line of the first line, it is printing 10296. What is this 10296? It's a process ID. Process ID of what? Parent or child. If you now you can, if you go back and try to understand the program, then I hope you will understand that it should be the process ID of child, because the fork return the process ID of child to the parent. And this the first line, this line is printing from the parent process. Why? Because it is printing from line number 7, line number 10, and at line number 10 only a parent process can come. So let me here again do the same thing. I'll go for ps minus af. See, if we go here, there are two out executing. First out is 10295, that is fine. Second child is 10296. I think you can verify with here also 10296, 10296. So child process is 10296, and both are executing. One is in core 1, one is in core 0. Okay, so now I think this parent and child part is clear to you, that how you can detect children, how you can detect it's a parent after creating after executing a fork. I hope it is clear to you. So now let me complicate the code little bit, and now what I will do, instead of all this thing, let me write a for loop here. Integer I equal to 0, I less than 5, I plus plus, and then inside this for loop, what I'll write, that if fork equal to 0, then break, otherwise continue hello world, hello world. Infinite is not required. What will be the output of this code? What do you think? I'll say that the hello world will print 6 times. So what I did wrong is I have not removed this fork. This fork is not required now. In fact, these two lines are not required now. I was trying to explain something else. Okay, this is the code. If this is the code, then it should print hello world 6 times. See, one, two, three, four, five, and six. So it is printing 6 times. Why it is printing 6 times? That's why this concept of fork is as I said, it's first it is simple, but the one by one will go to the complex side. Try to understand this code, what this code is doing. All the technique is in line number 7. It's a five. Line number 5 is a simple for loop, but that simple for loop will not be a simple for loop. You can, if you ignore this break. But now there is a break at line number 6. So what this line number 6 is doing, it is creating a fork. Fork is, it is creating a new it is creating a child process. So after line number 6 there will be two process, and it's a short form that fork returns 0 to child, fork returns non-zero to parent. So it's a short form I've written. I hope if you understand the C programming, you'll understand this short form. If fork, first of all, I'm calling fork, and if fork is 0, then it's a child process. So if in case of child process, I'm simply breaking it. I'm simply breaking it. So if it is a break, then from line number 6, where it will jump to line number 8. So it means that every child process will execute line number 8, right? And how, what is the behavior of parent process? Parent process will start from line number 5. When I equal to 0, it will go to line number 6. It will create a fork. So fork will create a child, and parent will be remain same, but child will directly jump from 6 to 8 because there is a break, but parent will not break because this break is only for child. So what parent will do, parent will again go to line number 5, and it will create, and for now I equal to 1, it will again enter line number 6, and again at line number 6 it will, there is a fork. So parent will be there, but a child will also create, and child will directly break, and it will go to line number again. So child will again go to 8, and parent will not break because break is only for child. So parent will again go back to line number 5, and now it will increment for I equal to 2, and it will continue. So that's why this for loop will create 5 different child, right? From 0, 1, 2, 3, 4, 5 child will get, and every child just after creation it will jump from line number 6 to line number 8, and it will print hello world. And what parent will do, parent will one by one it will create all the 5 child, and then after this the for loop will be finished, and it will go to line number 8, and the parent will also print hello world. That's why there are six hello world printing in the screen. I hope it is clear. If it is not clear, try to understand it. Try to understand it by yourself. And again, I'm reminding you, if you don't understand these basic concept about fork, then it will be difficult to understand my remaining lectures. Okay, I hope this part is also clear. Then let me move and make this even more complicated. Okay, this is another interesting program. So here again, try to understand the program up to line number 6. It's very easy. After line number 6, the line number 7, it's saying line number 8 and 9 will can execute only by child process, and line number 11 and 12 can be executed by a parent process only. I hope this is clear from the previous program. So now what will be the output here? There are two printf. So the first printf is for child, second printf is for parent. So and both printf are printing a value of x. So what value will be printed by line number 9? What I'll say that line number 9 will print 13, and line number 12 will print 11. So why it is like this means, if suppose if we assume like this that line number 8 has executed first, so if line number 8 executed first, so 12 is already become 13. So when at after this, when we'll try to use line number 11, then it will again, my 13 minus means again it should be 12. Or if we go for other direction, and if we assume that x minus is executed first, so 12 will become 11, and then again we'll go for x plus plus, then line number 9 should print 12. But what the output is completely different. Output is line number 9 will print 12 plus 1, that is 13, but line number 11 12 will print only 11. Let me show you this. Let me run this code. Okay, See, it is showing 11 and 13. 11 and 13. Okay, let me give you a new line. Yeah, that is another interesting thing I'll tell you here. See, line number 11, line number 13. Line number 11 means, see, line number 11, line number, so what is line number 11? Line number 11 is this, right? So to make it more, I'll write parent. Parent value, child value. Compile and run again. See, the parent value is this, the child value is 13. So parent is 11 and child is 13. So first thing here, you'll maybe say that, see, if you check the program, line number 9 is coming first, line number 12 is printing first, and line number 9 is printing last. Why so? Can you give me an answer? You may pause the video and try to understand it. If you understand it, then I think half of the concept that I'm discussing today, you have understood it. Okay, I don't have time to pause here. You have to pause by yourself. Let me explain it. See, line number 11, 9 and line number 12 are not executing by a single process. As I said, line number 9 will be executed by child and line number 12 will be executed by a parent process. So since these two are two different processes, and as I've already shown you in this terminal, that if there are two processes, then these two processes are independent thing. They'll execute independently, maybe in same code, may not be in same code, but they are independent thing. So when there are two independent processes running on a processor, it is not under your control that which one will execute first, which one will execute last. It's not just one program. If it is a one program and lines are written in sequentially, it's a different thing. But this nine number line and 12 will not execute by two single process. These are two different process. So you cannot guarantee which one will execute first. If I keep on executing it here, maybe sometime line number 13 will come first, and sorry, the child value will come first and parent value will go next. So this is the first point I want to explain here. The second point here is, at the beginning of this lecture today, I said that the moment you create every process has its own address space, right? And the moment you create use fork, it will create a child process, and the complete address space of parent is copied for there will be a copy will be made make for this the address space of parent, and it will be assigned to address the address as address space to children. That point is very important. The address space of parent is copied, and it's create a separate address space for child, and initially the values will be same. So if you see at line number 4, when there is only one process, the parent process, the value of x is 12. So at this moment, if we go to line number 6 and go for fork, then parent is fine. There is address space for parent, but there will be address space will be created for child, and the value of x will be copied there. So the after line number 6, the x is not a shared variable, right? It's not a shared variable. For child process, there is a separate x. For parent process, there is a separate x, because the address space is not shared. Address space is copied, and now there are two address space. One is for process parent, one is for child. You have to understand this. That's why at line number 8, when you are doing x plus plus, it is only incrementing the value of child x. The value stored in child process is implementing, and at line number 11, when I'm decrementing the x, this x is the x stored in the address space of parent. So you are just changing the variable of x in the parent address space. So the address space are different. That's why they are printing, one is printing 13, another is printing 11. So I hope this concept is also clear. Again, I'm advising you, all the program that I am writing today, one by one, I'm increasing the complexity. You should understand this basic things, and then only the concept of the book will be also understandable to you. The all this concept of book is depend on this fork child, and also you should understand the basic concept about fork. Now I'll explain you another important point here, and I hope this program is clear to you now after all this discussion. What will be the output of this program? I'll not execute it, just tell you. I think you will understand it, that child will print line number 7. This is child, and parent will print line number 9, that is this is parent, that's it, this is the output. Now what I have said that there is no guarantee that which order it will print, right? So if I go this to the terminal and if I compile this code again, okay, there is a small issue. X I have removed, so it should be like this. So if I compile this code again and if I run it, let me run it few more times. So if I run it, then parent is printing first and child is printing second. As I said, you these two are two separate processes, so you cannot guarantee that which order they will print. But if I write a wait here, wait null, I think wait should, for wait we should use include dot h, I think. Okay, let me run this code again. Yes, it is running. What will be the output now? If I go for output, then first of all, this is child will print, and then this is parent will print. See, this is child is printing, and then this is parent is printing. Why? What is the difference? So again, the wait command means wait we normally use from parent. So wait command means the at line number 10, parent will wait for terminating the child process. Okay, so start from line number 6 again here. I'll try to explain. So line number 6, it's a fork statement. Fork statement will create two processes. One is the parent, and another will be child. So line number 7 will start executing by two processes, parent and child both. So when parent will start executing line number 7, it will find that okay, PID is 0 or not. At parent, it will not be 0. So parent will directly jump to line number 10, and the moment it will jump to line numbers from 7 to 10, it is a wait statement, wait null. It may, and this it means that I have to wait here, the parent has to wait here until the child process has been terminated. And what child process is doing at line number 7, again it will start executing, it will find that okay, PID is 0, yes it is 0. So the child will enter at line number 8, it will print this is child, and after printing line number 8, the child will go directly to line number 14. Yes, because it's a if statement. So after 8, child will directly go to line number 14, and its return means the child process will be terminated after return 0. There are multiple ways to terminate a process. We can terminate a program by pressing Ctrl C, or we can terminate a program by writing exit command. We can also terminate a process by executing return 0, or we can also terminate by sending a signal. Child will terminate at line 14. So after terminating line 14, 10 line for the after terminating child at line 14, line number 10 of parent will allow to execute the next line, that is line number 11. So I think needless to explain here that line number 8 is can be only be executed by the child process, and 10 and 11 can only be accessed by the parent process. So if I write a while loop here, while 1 sleep 2, it's an infinite while loop, then what will happen? Let me compile this code again. See, that's why I'm saying it interesting, but you have to build it step by step. Now if I execute it, see, only this is child is printing, but this is parent is not at all printing. Can you guess what is the reason? Try to guess it. Okay, the reason here is the child process is it's printing this is child, and after this line number 9, the child process is entering into infinite loop. So now at this moment, child is just keep on executing this line number 9. It's an infinite loop. And you can see the line number 11 of parent. Line number 11 is actually the parent code, and parent code is waiting to terminate the child. But at line number 9, we can see that child will never terminate. It's an infinite loop. So at line number 10, the parent will always just keep on waiting for this, because 9 will never terminate, so 11 will not succeed, and it will not allow to go to line number 12. So it's a infinite situation, and it's a infinitely means after printing child, the after printing this is child, here the child process will keep on executing, so it's not possible for parent to print line number 12. Okay, now let me do another interesting thing. And now what I'll do, that you will see that it parent process will start executing automatically. let me say ps under af. So now there are two out dot o as expected. One is child, one is process, one is parent. So which one should be the child? The process which is created late. So I think 10916 is the parent and 10917 is the child. Okay. So now somehow from command here, if we somehow we can stop the child here. So here you can see line number 9, it is continuously executing. So if somehow now if line number 9 is can be means the child process can be terminated, then the moment you terminate the child process in parent, when where it is waiting for this terminating of child will succeed and it will print 12, line number 12. So let me use the kill command. Kill command I'll explain you again when I'll explain you signal in the same chapter. But you can, if you are interested, you can quickly go through the concept of kill from any internet, any website. So now what I'll do, I'll kill which program I want to kill, the child process. So note down the child ID, process ID, child process ID is 1010917. So I want to kill 917, the child process. The moment you kill child process, line number 11 of parent will succeed and it will print line number 12. This is parent. Just see the magic. You try to understand this and this. When the moment I'll press enter here, you start observing after this is child. Okay. See, it has printed this is parent. Did you understand what I am trying to say? That's why I said that my way of teaching will be more in practical way. If you understand, if you can relate your understanding with whatever I am saying, if this part is clear, then reading the textbook will be very very easy for you, and you can easily complete one chapter a day if you know all this concept. Now I'll move to a new program, and the purpose of this program is little bit different. Little bit different means uh okay, weight is clear, right? What does mean by weight? There are some more concept about weight, but I'll not discuss this today. I'll start explaining all these things from next class. But at the before finishing today's class, I want to explain you another important point here, that is called multi-programming, or you can say the concept of multi-core architecture. What do you understand by multi-core architecture? I think after covering all this 1.5 months of computer architecture courses, I hope you understand what is called multiple core, multi-core processor. Nowadays, every processor, if you go to market and want try to purchase i5 or i8, if you go for i5, there are four internal cores. If we go for i8, then there may be eight internal cores. So what these core are actually, they are in, they can consider them as a independent processor but installed in a single die. That's why I call them as a core, right? So if you have, what is the purpose of multi-core architecture? That if you have multiple application or multiple processes running in your system, then what OS can do, OS can share these processes among multiple core. Okay, if there are four cores and you have eight processes, maybe OS will say the first two should be executed in core one, second two should be executed in core two, like this. It will divide this task among the core. That's the benefit. Okay, so what this if you see this code, only important thing is here. So this the same thing is executing by parent, the same thing executing by child also. But what it is doing, it is just taking some time here. Don't go for the logic. The logic here is I want to spend some time, I want to give, because this is a power is already a complex operation and I am repeating it for many times. So line number 14 and 15 is just I am trying to do some calculation which takes some time. That's why I'm using all this huge number and all. That is nothing fancy here. The same thing I have written here also. Here also I want to spend some time. I want to see how much time it is taking to complete this operation. Okay. And after this, you can see line number 19, it is waiting for the child. So no matter, either this part will execute fast or this part will execute fast, or they are executing as concurrently or parallelly, that's not an important. But line number 19 will only succeed after completing the child process. So the when child process will complete, it will return at line number 19, and that, and again line number 20 and 21, I'm calculating the total time taken. Okay, so this is the total time taken. And this in the syntax of time I am not explaining here. You can see the header files are here. After header files, what are the I'm showing you the complete code now. This is for time, storing time, and then this is the start time, then this is the end time, and now I'm finding the difference and printing it in seconds. Okay, now let me run this code. GCC, I think this is the different name. Name is multi multi. I think this program is not in this folder. So if I try to compile this code, it's multiprogram.c. Then if I compile it, okay. So since I'm using mat.h here, then I have to use minus lm or minus o out.o. Okay, the program is executing, and if I run this program, how much time? See, it is taking some time. Why it is taking some time? Because both parent and child are calculating something. What it is calculating? It is calculating this operation, and this operation is a little bit time consuming. I've intentionally written a code which can spend some time in computer to make it executed. Okay, so you can see the time taking is 4 seconds. Why it is taking 4 seconds? Let me explain you again. There are two threads actually here. This not just there are two processes actually. So if there is only one process, and if I try to run this, then it will take there is only one process. But what suppose there is a task, and I'm saying that 14 15 and 17 18, these are the time consuming part, but this time consuming part is not executing. Both are not executing in the same process. 14 and 15, line number 14 and 15 are belongs to child process, and line number 17 and 18 belongs to parent process. I hope it is clear, right? And after this there is a line number 19. So line number 19 is waiting for completing the child process and also the completing the parent process, because at parent you can only reach 19 after executing 18, isn't it? Jab tak 18 chalega 19 aa hi nahi sakta, right? So if you are in 19 means 18 is already done. That's why you are in 19 at parent, and that line number 19 is waiting to completing that part of child. So it means once you are coming out of 19 and you are at line number 21, it means that the execution of both parent and child has been done. So that's why I'm again recording the time. At line number 11 I am recording the start time, at line number 21 I am recording the end time, and then I am printing the total time taken as 4 seconds. That's it. So now let me show you one thing. Let me run it again. Okay, I should make this ready. Let me run it here, and let me go here and run it here. You can see here now there are two out, child and so it's already done. It is taking 6 seconds. That's fine. But see here, if you go there are two processes. This is the child process, and this is the parent process. This is the child process, and both are executing, right? Both are executing something, this concept. So since there are two processes, and you can see the both processes are running on core 0. So let me run it again, and let me run it. Now it will take 4 seconds. It is taking 6 seconds again. Okay, but now in this case, see, it is running on core 0. It is running on core 1, right? There are two processes. One is running on core 0, one is running on core 1, and it is taking 6 seconds something. So let me run it again. It's taking 5 seconds, so it is taking 4 5 6 kind of thing seconds. So now what I'll do, I will let me check how many cores are there in this process. LSCPU. If we go for LSCPU, then it will show me that how many cores are there. If I go here, there are only two CPUs, right? There are two cores here. So what I'll do now, I'll disable one core. Which core I want to disable? I want to disable cores 1. There are two cores. So disable a core, you can use this command. If you go for this command, then this command will disable CPU 1. If you want to enable that command, you'll go for echo 1. So echo 0 means it will disable. So I want to disable a particular core. So what I'll write, uh, see, so now core 1 is disabled. So now only one core is there, core 0. So now if I run this code again, let me see how much time it is taking. Mhm. It is taking 9 seconds. Why it is taking 9 seconds now? Because let me go to the code again. If the sorry, this was the code. So if this is the code, now it is taking, so this part is clear, right? There are two process, child and parent. There are two process, and you have only one core now because this machine has two core, but one core have is shut down now. So there is only one core running, and you have two process, parent and child. So it is means both child process and parent process are executing at core 0 in a context switch manner. It means when one process is executing, another process cannot execute. When the child is executing, process is in ideal. When process is executing, child is in ideal. So they are executing concurrently, not in parallel, so in interleaved way. So that's why it is taking almost double time. But if both the processes are on, let me again change this line and echo 1. Echo 1 means the CPU 1 will be again activated. Now CPU 1 is again activated. Now if I run the same code, it will take less time. It should take less time. It should not take 9. Just wait and check. See, it is taking 5, not 9. So what is the difference there? The concept that I am trying to explain here is not the concept of process, but it's the concept of architecture. The what is the advantage of multi-core processor that I'm trying to explain you. If you go for now, at this moment there are two cores executing. Since there are two core executing, the program that I'm executing here is two process, parent and child. So parent is executing in one core and child is executing in one core in parallel mode, not in concurrent. Concurrent means in context switching manner, it may not be parallel, but since there are two independent cores, in that case both can work parallel, not context switching way. Means context switching way means when one is executing, another is not executing. That is called concurrent way. It's not concurrent, it's completely parallel, and that case the time will be saved. So it is taking only 5 seconds. That's why this is the importance of multi-core processors, right? But if you have a multi-core processor, for example, this laptop that I am using has two core, right? This it has two core, but still if I write a flat program here, instead of creating a fork, and I'm not creating two process, instead of this, if I have only a single process and I want to do a complicated task, it will still run on a single core, right? If there is no fork statement, if I am not creating any process. That's why if you have a multi-core processor, then to get the benefit, it is also the responsibility of software designer to design the software in such a way that the program can be divided into multiple programs, multiple processes, or multiple threads. Threads is not important. I'll cover thread later, but at least multiple processes, such that the multiple parts of this software can be executed in different cores. So that's the advantage of multi-core. And in conclusion, again, I'll say that to get better benefit from a multi-core machine, it's also it's also the responsibility of programmer to write efficient programs. Okay. So the last topic that I have discussed here is interesting, but this topic is not included in your book. But I think it's an interesting one, so you should follow it. And whatever commands that I have written, all these commands are important to try to follow all these commands. Okay. So I'm stopping this lecture here. Next lecture will again continue from this program, and we'll again extend this program. We'll try to write more complicated programs from this. Okay. Thank you for watching this video.